Welcome back, guys. So today we'll be solving another LeetCode question. So this time we have climbing stairs, which is easy, and it's LeetCode 70. So let's get into it. So you're climbing a staircase. It takes n steps to reach to the top. Each time you can either climb one step or two steps. In how many distinct ways can you climb to the top? So for this problem, I'll be highlighting two ways. First way, obviously it won't get accepted. It is just to make you understand the recursion. And the next step is like the dynamic programming DP array, which directly stores in like the number of ways for each of the indexes, and then we can return it at the end. So yeah, for example, we have let's say n is equal to 2, and then we have the output or the result to be 2, because we can either take individual steps 1 plus 1, or we can directly take 2 steps. So that is 2 ways to climb when n is 2, and then when n is 3 we have 3 ways. So individual step 1 plus 1 plus 1, and then 1 plus 2, and then 2 plus 1. So there's like 3 ways where you can reach to the top. So for this question, like thinking of recursion, we have like two cases, which is like two base cases, which is possible. So one where from the current step, you reach the final step or the end step where it is equal to, then if the current step is equal to n, that means you have found a successful way to reach to that end step. So then you add to your count or whatever, like the counting the number of ways, you add 1 to it, so we can just return 1. But then if the current step crosses the final step, suppose you are on the 19th step and you are reaching, let's say, 20th step, so you can either take 1, which makes it 20, which is a valid way, so you add 1 to that case. But you can also take 2 steps, which makes it 21, where you have crossed the final step. That is not the right way, so you return 0. So those are the steps, like the number of ways. And then we can, like, since it's asking how many ways, we can just return the sum of those two recursions. So you'll understand when I get into the code. I'll just have like a helper function over here, which takes in our current step and the final step. And so the base case is, as we discussed, if the current step is equal to the final step, that means it's a valid way, so we return 1 to that previous call. And if current crosses n, then we return 0, so that's not a correct value. So then we just have, there's two ways, like there's two choices. Either you can step once at a time, which is again helper, so we add +1 to the current value and pass the same n, or you can take 2 steps at a time, which is helper +2 / n, and then the total number of ways is just step 1 plus step 2. So we have our helper function over here, and for this we just have to call the helper function. So helper, so we start from the 0th spot, and then our goal is to reach to the end. This should pretty much return, let's just, yep, yeah, so we have it for the test cases. Let's try to submit it. Obviously, since we are using recursion, it's redoing a lot of steps, so every time n we calculate, even though it has been calculated before. So as you can see, so for example, n44, our stack time limit exceeds. So for this, let's go ahead with like the second approach. This is just to get you started with recursion, so it's easier to visualize it this way. That's how I think of it. And then, so now, just to make things easier with dynamic programming, we have let's just take like a simple dp array. So in this method, we just calculate, for example, let's say the end is 20, and instead of calculating 20, we just build the array from ground up. So we say, oh, zeroth spot, I'm already there, so that's one way. So first spot, it takes one way to reach to that spot. Let's say n is equal to 2, it takes 2 ways to reach to that spot. N is equal to 3, it takes the previous one, like the one-step method, plus the two-step method to reach to that spot. So we are building the array from ground up here. So we'll have a dp array of size n plus 1, which is initially filled with all zeros, and then obviously dp of 0 is 1. That means you're already in, like if n is 0, you're already there, you don't need to do anything. And then dp of 1 is still 1, like to reach n is equal to 1, you have only one way. And now from 2 onwards until the nth spot, we are building the array from ground up here. So for every, like if we map it down, for every ith array, this spot, there's only like, if you have already calculated the previous 2 values of the array, you just have to add them and like get the total number of ways for the current ith spot. So for example, dp2, let's say, like the third indices of this dp array is just the summation of dp0 and dp1. So as we saw in the example as well, so when n is 2, the result was 2 ways, there's 2 ways. So what you can do simply here is to dpi minus 1, which is like the total number of ways for the I minus 1th step, and then dpi minus 2, which is like the total number of ways for the I minus 2th spot. So for the current spot, you can have these summations to give you the total number of arrays. So then we just return dp of, for the nth one, we just return dp of n. So I think this should work. Let's see. Yeah. So let's go ahead and submit it. Let's see if this works. So this is building the array from ground up. So yeah, so this works and we have it there. So climbing stairs, pretty simple problem in a recursive way, but if you have to come up with a DP solution, it's better to like solve the recursion first and then map this solution, so it's easier to visualize. So yeah, there you go.